Welcome to Chemistry Tales. This is Tale 3-3, in which we hope to be able to calculate a cell potential when using the Nernst equation. We are doing this in completion of our laboratory experiment in which we reacted dichromate solution with iron. The first thing you need to do is balance the redox reaction so you know the stoichiometric coefficients between the dichromate iron in its 2+ oxidation state, and chromium in its +3 oxidation state, and the iron in the 3+ oxidation state. Once you know that, we are predicting the cell potential after the addition of 10 milliliters of our 0.025 proximate molar potassium dichromate solution. We need to use the redox couple of the iron half-cell reaction. Write the Nernst equation for this half reaction. It's that under standard conditions minus the constant over the 1 mole electron exchange, log base 10, iron in its reduced form over iron concentration in its oxidized form. Thus, we need to get the moles of each of these species and divide by the total volume of the solution. To get the moles of the iron 2, we need to start with the initial number of moles we had before the reaction started. This comes from the equivalence point determination. We can convert moles of the dichromate ion to the respective moles of the iron. Then, with that initial concentration of iron, we need to predict the number of moles that react after the addition of the 10 mL of the dichromate solution. To get the moles of iron that reacts, we need to know how many moles of dichromate are in 10 milliliters of a 0.025 molar solution. The difference gives us the moles of iron. The moles of iron 3 we get from the balanced reaction, and knowing how many moles of the iron 3 we get for the known number of moles of dichromate ion that were reacted when we add 10 milliliters of this solution. This should be all you need. Thank you for listening, and Annie and I say good evening, and please send us an email if you have any questions.